Friends, in the previous videos, we discussed how to find out the adjoint of a matrix of the order 2 cross 2 of the order 3 cross 3. Clear? And now, today's class, I am going to discuss the theorems. So, this theorem is very important. Please try to remember the result. So, usually in your annual examinations, in Karnataka board second PUC examinations, they don't use. The result is very important. But sometimes they may appear, but usually they don't ask. So better the know, if you know the proof, then that's a very good to you're very good. Clear? So for that reason, what I'll do, just I'll verify this theorem. So what is the theorem given to you? The theorem is already I wrote the statement. So what is that? If capital A is the AB any square matrix of order n, then A into adjoint of A is equals to adjoint of A into A, and this value is equals to determinant of A into I. So here this adjoint of A is I, just I, here adjoint of A is second I wrote, that I wrote here is first. So A into adjoint of A or adjoint of A into A is equals to determinant of A into I. And what is I, my students? Where I is the identity matrix of order n. Clear? So this is the theorem we have. So now to prove this, to verify this, I'll take the one example, the matrix of the order 3 cross 3. So by taking that, we can verify this theorem. So let us take, my students, one example. Here it is. To verify, here it is verification. Just I verify this. So verification here. So how to verify means, for this verification, let us consider. So consider, or let us consider A is equals to one matrix. I am going to consider A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the matrix of order 3 cross 3 I am considering, my students. And now we know that what is the adjoint of this A. So adjoint of A is equals to, how to write the adjoint of A? So if this is the matrix, means adjoint of A is nothing but, here it is transpose of, here it is transpose of A11, A12, A13, A21, A22, A23, A31, A32, A33. Clear? So this is what? This is adjoint, here it is. This is the adjoint of A is nothing but transpose of A, capital A11. What is capital A11? Capital A11 means this is the cofactor of the element A11. That we will denote it as A, capital A11. So small A11 means this is the element entry of the matrix A. But the capital A11 means it is nothing but the, here it is cofactor of the element A11. Capital A12 means cofactor of A12. A capital A13 means cofactor of A13. And in the earlier class I told to you how to find out the cofactor of the any element. Clear? And now, my students, we should take the transpose of this. So therefore, this is nothing but, here it is. So this implies adjoint of A is equals to transpose of this. I should take the transpose of this matrix. So how to find the transpose of the matrix? So transpose of the matrix can be written by interchanging rows into columns. So this first I am writing it as first column. I should take the transpose of this. For that reason I am writing here this. So transpose of this matrix is, here it is A11, A12, A13. First row I write it in terms of the first column. So second row I will take it as the second column. So A21, A22, A23. Third row, here it is. Third row I will write it in terms of columns. Clear? So therefore A31, A32, A33. So this is your adjoint of A. Clear? And now, my students, I should prove that this result, A into adjoint of A. So I take here this, then A into adjoint of A is equals to. So I should prove this result. Clear? So I will take this one and I will prove this. Clear? For that reason I am taking here this A into adjoint of A. What is A then? I already took here this. A is nothing but, here this. What is A here? A11, A12, and next here it is A13, A21, A22, A23, and next A31, A32, A33. So this is your matrix A into adjoint of A. So what is adjoint of A then? So here it is, adjoint of A. Already I have here. What is that? A11, A21, A31. Clear? So I'll write here this A11, A21, A31. Next A12 and next A22, A32 and next A3, A13, A23, A33. Clear? So just I written the values. A is nothing but this matrix, this I wrote, and adjoint of A is nothing but this matrix that I wrote. A11, A21, A31, A12, A22, A32, A13, A23, A33. This is what I wrote here. It is clear. And now, my dear students, we know that. So please remember what we know that here it is. We know that here in the previous classes I learned the one result, or else we learned the one result. What is that? Two results we learned. So what is that? That is nothing but here it is the sum of, here it is the sum of, here it is, I'll write first the sum of product of any elements of, here it is any elements of either elements of the row or column if I multiply with corresponding cofactors. Clear? So here it is with the corresponding cofactors. If I multiply means that will give us the determinant value. Clear? So what is that? The sum of product of, here it is, elements of any row or column with corresponding cofactors. If I multiply means here it is, then that will give us the determinant value. This I discussed in the previous classes, previous videos I discussed this result. Clear? So what it means? It means here it is, just you should observe here it is. A means it is element, A11 means it is the element, capital A11 means this is the cofactor. So how to, in short, how to remember, or here it is, the trick how to remember this result means just you should observe here it is. Here what is the subscript? A subscript is 1 1, and what is the cofactor A? Here it is the capital A subscript is also 1 1. If the element subscript and the, here it is, cofactor subscript are same, here it is, you can observe here it is, A11 capital A11, A12 capital A12, A13 capital A13. If the subscript, both the cofactor as well as the elements subscript are same, and if you take the sum of this means that will gives you always the determinant value. This is the first result we discussed. Clear? And another result I have given to you. What is that? If you take the any elements of the, here it is, the sum of the here it is product of the any elements of the row with other any row or columns cofactors, if you multiply means that will gives you the value 0. Clear? That value will give is the 0. For example, you can take A11 into, here it is, A21 plus A12 into A22 plus A13 into A23. So this will give you determinant value is equals to 0. These are the two results I discussed. You can observe here it is A11, A12, A13. It means these are the elements of the first row. To the elements of the first row, I multiplied with the cofactors of the other rows cofactors. I am multiplying. A21 means this is the second row cofactor. A22 means second row's cofactor. A23 means here it is second row cofactor. If I multiply like this, then that value will give you 0. So for that reason, what I am telling you, always please try to see here, observe here it is. Here A subscript is 1 1, and here it is A subscript, capital A subscript is 2 1. It means these two are not equal. So therefore the sum of this is equals to 0. So what is the result? So result is very simple. So what is the result? The sum of the product of the elements of any row or column, if I multiplied with the corresponding cofactors, then that will give us the determinant value. Clear? And next, to the elements of the any row or column, if I multiply with the any other row or columns cofactors, if I multiply means that value is equals to 0. So instead of remembering all these result, you should remember, observe here it is, if the subscripts are same with the cofactors, then you can call that, you can have the result that is determinant value. But if the subscripts are different, then that value is equals to 0. So this is what two results we discussed in the previous videos. And now these results I am going to use here it is to solve this result. Clear? So here it is. So now I will consider here this. Now my additions, take this a into adjoint of a. So in this case you can observe here it is a into adjoint of a. So now I will multiply these two. How to multiply here my additions? The multiplication is possible here it is like this, row into column. Clear? So a into adjoint of a is equals to a into adjoint of a is equals to, I am multiplying this matrix into this matrix. So first row into first column. So just imagine, if you multiply first row into first column means a11 into a capital A11 plus a12 into capital A12 plus a13 into capital A13. It means you are getting this case only. Clear? So this element into this element. So a11 subscript a11 plus a1 to this subscript and this subscript same. This element and this element a13 a13. It means you are getting this only. If you get this means what is the value of here? This value is equals to determinant of a. So therefore here it is first row first column gives us the determinant of a. And next one is first row second column. So first row second column means this I will multiply. So a11 into a21. So a11 into a21 means this subscript is here it is 1 but this subscript is a21. It means you are getting this. First row into second column, if you multiply means you are getting like this. If you get like this means the value is equals to 0. So therefore this place element, if you multiply those matrices means you will get 0. Similarly, the first row third column. So first row third column, here also you can observe here. What is that? Here it is this element into this element. So here it is a11 into a31. a11 into a31 means this subscript is different and this subscript is different. So therefore that value is also give you 0. Clear? And similarly my dear students, you can observe it is second row first column. So if you multiply second row, this second row first column means a21 a11. Again here these subscripts are different. This value will give you 0. And next if you consider second row second column, a21 plus a22 into a22, a33 into a23. It means if you multiply second row and second column, so these subscripts are same. Here it is a21, here it is a capital A21 plus a22 into a capital A22 plus a23 into capital A23. It means you are getting this result like this. I mean the subscripts are same here, so therefore this will gives you the determinant of A. Similarly, second row third column, here also a21, here it is a31. Here it is, it means subscripts are different, so therefore that value is equals to 0. Clear? And similarly next here it is third row first column. So third row first column a31 a11. Again here the subscripts are different. This value is equals to 0. And next third row second column a31 a21. Again different. So therefore the value is equals to 0. But if you take third row third column a31 into capital A31, subscripts are same, plus a32 into this capital A32, so subscripts are same, plus a33 into a33. So therefore this will give you determinant of A. Am I correct? Yes. So therefore you can have here this I can write it as, so this is equals to, so from this I take the determinant of A common. So if I take determinant of A common, what is remaining my students inside the bracket? I took the determinant of A common factor. Outside the bracket I am taking. So here it is 1 0 0 0 1 0 0 0, because here this determinant of A, if I take common means 1 is remain, and in remaining places 0 is there, 0 0 0, and here it is 0 as it is, 0 as it is I wrote, but here is determinant of A is there, determinant of A I am taking outside, what is remaining? 1. Similarly here, so this can be written as, so therefore this can be written as determinant of A into, this is what your identity matrix of the order 3 cross 3. Similarly, next my dear students, here it is. This I will write clearly, A into adjoint of A is equals to determinant of A into I. So this value is equals to this value. Can I write? I can write like this. And now my dear students, similarly we can prove the similar way. We can again you can take first only adjoint and then you can multiply to the matrix A. So similarly, adjoint of A into A. If you do the multiplication like this, adjoint of A into A, so again you will get determinant of A into I only. Clear? So therefore we can have this result. So A into adjoint of A is equals to, here it is, adjoint of A into A is equals to determinant of A into I. This is what our required result, where I is the, this is nothing but the identity matrix. So this is what our required result. So very important result. So based on this, I will solve the some more questions also in some, while proving some theorems it's required. In CET also it's very useful to you. So please try to remember this result. Usually they don't ask the result. If sometimes if they ask means you should able to write this. Clear? I hope you understood. Still if you have any doubts you can comment me. I reply for that. Clear? We'll next move to the some more theorems, or we can take it as the results. Please pause the video to note it down. Yes, my students, next concept we are going to discuss is, that is, singular and non-singular matrix. So before studying the definition of the singular and non-singular matrix, first of all I will take the one example. So I take here it is one. I took one square matrix of the order 2 cross 2. So this is the one square matrix. So here what I will do, I will find out the determinant of this. So the determinant of A is, the symbol will denote like this. Clear? So how to find out the determinant? Determinant can be found out of the order 2 cross 2 by multiplying this element into this element. So 8 1 to 1 is 8, minus of this element into this element, 4 2 is 8. So this is equals to 0. So this implies the determinant of this matrix is equals to 0. Clear? So therefore the definition of a singular matrix is, so what is singular matrix? The singular matrix is, here it is, definition I am taking, here it is, definition of, here it is, singular matrix, or else here it is, yes, the definition of singular matrix I am taking, here it is. So what is that? Here a square matrix, we should consider the one square matrix, a square matrix capital A is said to be singular. So one square matrix, a square matrix A is said to be singular if determinant of A is equals to 0. So if you consider the any one square matrix A, then if the determinant of this is equals to 0, if you got the answer as 0, then that you can call it as, then this A you can call it as singular matrix. Here you can write here this. Hence this is example for singular matrix. Hence A is singular matrix. Singular matrix. In this particular example, A is said to be singular matrix because if I consider the determinant of this matrix means that determinant value I am getting it as 0. So therefore, A is called as singular matrix. So what is the definition? Singular matrix definition is a square matrix, capital A you can consider. A square matrix, capital A, is said to be singular if determinant of A is equals to 0. If this condition satisfies, then you can call here it is the A is a, here it is singular. Clear? And next I am going to discuss non-singular. Then what is meant by non-singular? So that is very simple. So if determinant of A is not equals to 0, then such square matrix we can call it as non-singular. So here also just I am discussing it is non-singular. So what is non-singular matrix? The non-singular matrix here it is. So non-singular means a square matrix. A square matrix A is said to be non-singular if determinant of A is not equals to 0. So very simple definitions, my dear students. So what is that? A square matrix A is said to be non-singular if determinant of A is not equals to 0. Then such a matrix we can call it as non-singular. You can take the example also here. Even here I can take one example. So I'll take one example. A is equals to, here it is 1, 2, 3, 4. So this is the one matrix, one square matrix I considered. Now if I calculate the determinant of A means, what is the determinant of A? 4 into 1 is 4, minus 3 2 is 6. So here it is 4 minus 6 is minus 2. Clear? So minus 2 is not equals to 0. This implies determinant of A is not equals to 0. It is not equals to 0 because the determinant of A, what is the answer I got? Minus 2. Clear? So therefore this A is called as, hence A is non-singular matrix. Hence A is non-singular matrix or non-singular you can call. So these are the definitions, very important. So even I given to you examples also. Clear? And next, my students, we will continue in the next class the some more theorems. We will state the theorems. The proof for those theorems is not in your not for your syllabus. So therefore, just I will state the some theorems, and after that we will discuss the problems. So up to here, if you have any doubts, you can comment me, and please pause the video to note it down. Thank you.